Welcome back, dear students. Let's continue with the first exercise on height and distance. So this is my third video on first exercise. So today we'll begin with question number 9, which says, at a particular time when sun's altitude is 30 degree, the length of the shadow of a vertical tower is 45 meter. So let me draw the diagram also at the same time. So let me first draw a ground, and on the ground there's a vertical tower. Okay, so this represents a tower for you. Okay, now question saying when sun's altitude is 30 degree, all of you know, if the sun is out here, like this, then what happens is you get a shadow, isn't it? So when you form a shadow from this point, okay, so when you form a shadow from this point, let's say, okay, so when you form a shadow from this point on the ground, okay, then the angle made is 30 degree. That's what is the meaning of the first sentence. Okay, so by the way, what is given? Length of the shadow of a vertical tower. So if you call AB to be the tower, and let's say BC represent the length of the shadow. Let's say BC represents the length of the shadow. Now this length of the shadow is given to be 45 meter if the angle of this or the altitude of this sun is 30 degree. That is, this angle is 30 degree. Is that clear? Question is asking you, find number 1, what is the length of the tower. It's pretty easy. We have seen this kind of some many number of times. Okay, so let's quickly find what is the length of the tower. So that explaining part you will do by yourself. Okay, so in triangle ABC, okay, so you see first and foremost this is 90 degree. Okay, so in triangle ABC we have, okay, so in triangle ABC we have, see, you want to find AB, right? So this is the given angle, side opposite to this, that is AB, becomes your perpendicular, and you have been given base. So using perpendicular and base you have to form tan theta, isn't it? So you have perpendicular, that is AB, by the base, that is BC, is equal to tan theta, right? So tan theta is how much? Theta is given to be 30 degree. Okay, so we have, let's put the value now. So AB, do we know AB? No, we don't know AB. By, we have BC. Okay, so BC is given to be 45 and tan 30 degree. So let's find out what is the value of tan 30 degree from the book. Okay, so I'm using book right now. So tan 30 degree is given to be 0.5774. So you can take that to be 0.58. Okay, so we have from here, what is AB? So AB turns out to be 45 into 0.58. Okay, so this is your AB. So let's quickly calculate how much is this. 45 into 0.58. So when you multiply, you get 26.1. Okay, so you get this to be equals to 26.1 meter. So that means I got the first answer. Okay, so therefore length of the tower is 26.1 meter. So this is my first answer. Remember, this is my first answer. Second question is asking you, find the length of the shadow of the same tower when sun's altitude is 45 degree. So basically there are two cases. We can say case A and case B. I'll do case A. Case B you try by yourself. Alright. So we have case A. Okay. So we have case A. When sun's altitude is 45 degree. Basically we are going to have the same thing. Okay, so only thing is you will have the change in this. So let me draw another diagram, a similar diagram here. So there is, first and foremost, you have the ground, you have the tower, okay, you have the shadow. Okay, so shadow is given to be now, okay, so the angle is given to be 45 degree in this case. Okay, so we have AB, okay, let me call this to be point C. Okay, and it is given that, remember, it is given that this time angle is 45 degree. Okay, now tell me, will the length of the shadow change if the angle is changed? Obviously, right? So the length of the shadow will change, but what happens to the length of the tower? It will remain the same, which is equals to how much? Which is given to be equals to 26.1 meter. Remember, length of the shadow will change. Okay, so the tower will remain this, the height of the tower will remain same, and we need to calculate BC from this case. Okay, so case B you will try by yourself, remember. Alright, so let's continue with our problem. Okay, so in triangle ABC again, in triangle ABC, so you have perpendicular and you are asked to find what is base. So let's again use AB by BC. Okay, so AB by BC gives you what? AB by BC gives you perpendicular by base gives you tan theta, and theta is how much? Theta is 45 degree. Okay, so AB, do we know AB? Yes, AB is 26.1 divided what is BC? We don't know. So BC itself, tan 45 is 1. Okay, so from here BC into 1 is BC, so you get BC equals to how much? 26.1 again. Okay, so BC you get this to be 26.1, which means that the length of the shadow is, therefore the length of the shadow is how much? It is 26.1 meter. So this is my second answer. Okay, that is number 2 sub number A. So this is my number 2 sub number A answer. So in the next case, that is case B, when sun's altitude is 60 degree, you will try by yourself. Right? Pause the video and note down your solution. Let's take another question. So just look at this question very carefully. Alright. So here question says, two vertical poles are on either side of a road. So there's a road. Okay, so let's say this is a road. Okay, so this is a road and there are two vertical poles. So this is my one pole, this is my another pole, let's say. Okay, so let me name the poles also. So let me take XY to be one pole. Okay, let me take this pole to be AB. Okay, so basically here BY, okay, BY represents the road. Okay, so this BY represents the width of the road, remember. Okay, so the road goes somewhat like this. So BY represents the width of the road. Okay, now a 30-meter long ladder is placed between two poles. Okay, so there's a ladder placed in between the two poles. Okay, now when the ladder rests against one pole, it makes an angle of, see here carefully, so with one pole it makes this much of angle, and when it turns to rest against another pole, it makes this much of angle. Now look at these two angles carefully. They are same angle, isn't it? So if they are same angle, what can you get from this? What information do you get from this question? It means that the pole or the ladder is kept exactly in the middle, because see, when you place it exactly on the middle, then only it forms equal angles with both the poles, isn't it? Okay, just imagine. Okay, so here what am I going to do is I'll place the ladder exactly in the middle, and from there I'll rest it against the two poles. Okay, remember the length of the ladder is going to be how much? 30 meter. Okay, so that's why it's going to be exactly in the middle. So let me call this point to be point C. You can call this point to be D, and you can call this point to be point E. Okay, see, with one pole it makes an angle of 32 degree. It is given to be, this is given to be 32 degree 24 minutes. Similarly, this is also 32 degree 24 minutes. Okay, now question is asking you one more thing. Length of the ladder is given to 30 meter, that is CD is 30 meter, and CE also represents the ladder, and this is also 30 meter. Okay, now you need to calculate the width of the road. That means you need to calculate what is YB. Okay, now for calculating YB, it's enough to calculate what is YC, because you know C is exactly in the middle. So how much ever is YC, same thing is going to be BC. Okay, so just find YC and multiply it by 2. You will get the length of YB. I hope this is clear. Okay, so the explanation part you will write by yourself. The necessary thing that we need to explain here, I'll write here. Okay, so from the condition, okay, or using AAS. Okay, using AAS. Why AAS? This is angle, side, angle, side, and this is also 90 degree, right? So angle, side. So using AAS, we say that triangle DYC is congruent to triangle EBC. Okay, so triangle EBC. Okay, now what am I going to do is I will make use of only DYC. Okay, so in triangle DYC, we have, okay, this is given, that is hypotenuse, this is your perpendicular, this is your base. So let's make use of base by hypotenuse. So you have YC by hypotenuse is BC. Okay, so base by hypotenuse is cos, isn't it? It is cos 32 degree 24 minutes. Okay, so it is, see here carefully. So here we have YC, we don't know what is YC. DC is known, which is given to be 30. Now cos 32 degree 24 minutes. If you look at your log table, it is given to be 8443. It is not 8443, but here it has to be 0 point. Okay, so this is the value of cos 32 degree 24 minutes. Okay, please remember, in your book only this much is given, but in front you have to write 0 point also. Okay, so that's why we have here, let me write the value. This is 0.8443. Okay, so from here what is YC? YC turns out to be 30 into 0.8443. Let me multiply these two. Okay, so when you multiply 30 into 0.8443 gives you 25.329. Okay, so therefore you need to calculate what? Width of the road, isn't it? So we have width of the road will be, you know, it is YB, which is double of YC, isn't it? So we have 2 into YC is 25.329. so when you multiply 25 into 329 with 2, you get your answer to be 50.658. so this is the width of the given road here. Okay, so you may pause the video and note down your solution. Okay, so we have another question. So I'm just going to give you a hint of this question, because this question is similar to question number, I think, 8. Okay, so here just look at the diagram carefully. Two climbers are at points A and B on a vertical cliff face. Okay, so let me draw a ground and there's a vertical cliff. Okay, so let me name the cliff as XY. Okay, so you have to mention XY is a vertical cliff. Okay, now on this cliff there are 2 points A and B. Okay, so let's say this is point A okay, and let's say this is a point B. Okay, to an observer C 40 meter from the foot of the cliff. So from foot of the cliff move 40 meters and that point becomes your point C. Okay, so from point C on the level ground, A is at an angle of elevation of 48 degree. That means from C, if you look at A, from C if you look at A, then the angle of elevation is given to be how much? 48 degree. Okay, so this time your angle is given to be 48 degree. Okay, and B of 57 degree. And if you look at B, from the same point, from C, then your angle of elevation becomes 57 degree. Okay, then your angle of elevation becomes 57 degree. So let me write it here. So this angle, wait a minute. So this angle is given to be 57 degree. Okay, now what is the distance between the climbers? That is, what is AB? That's what you need to find. So basically what you do is, using a smaller triangle find AY, using bigger triangle find BY. Now from BY you subtract AY, you get AB. Okay, so you try this problem by yourself. I have drawn the diagram for you. Okay, so pause the video and note down the diagram. Next we have a man stands 9 meters away from a flagpole. Okay, so there's a flagpole. First and foremost, let me draw the diagram here. So this is the ground here. So this is the ground. So there's a flag post. So let's say this is the flag post. Okay, and there's a man standing. Okay, so let me say this is the man. Okay, now let me label it also. So let me take AB to be the flag post, and let me say XY is the height of the man. Okay, which is standing 9 meters away from the flagpole. So YB is given to be 9 meters here. He observes that the angle of elevation of the top of the pole is 20 degree. That means if the man, obviously he looks from X only, right? Because X is the head. So if the man looks at the top, okay, looks at the top of the flag post, if the man looks at the top of the flag post, then the angle of elevation, okay, so let me draw a parallel line for drawing for finding angle of elevation. So the angle of elevation is given to, that is, this angle is given to be, so this angle is given to be how much? 28 degree. So this is the angle of elevation of the top of the tower, 28 degree. Okay, and the angle of depression, remember depression means angle formed with the horizontal when you look down. Now angle of depression of the bottom of the pole, so bottom of the pole is here. Okay, so the angle of depression of the bottom is given to be how much? It is given to be 13 degree. That means if you look down from here, the angle formed here is this one, right? So this is the angle formed. So this angle is given to be how much? It is given to be exactly 13 degree. So this is given to be 13 degree. Question is asking you, so this is 13 degree. Now question is asking you to find the height of the pole. Now let me name this point as point, let's say C. Okay, so let me call this point to point C. Okay, now there are two right angle triangles here, so this one and this one. So what am I going to do is, I'll find from each triangle, that is from this triangle I'll find AC, and from this triangle I'll find CB. Okay, so these two gives me, the sum of these two gives me the height of the pole, flag pole here. Okay, so is the strategy clear? Right. Okay, so let's without delay, let's see how to solve this. So first and foremost, if this is your 9 meter, this is also going to be my 9 meter. Okay, so you will explain all these things. Okay, so let XC be perpendicular to AC such that XY is equals to CB and XC is going to be equals to YB. All these things you will explain by yourself. So let me first look at triangle ACX. Okay, so in triangle ACX, okay, so let's see what do we have in triangle ACX. So we have to find AC, isn't it? So this is my perpendicular and this becomes my base. So again we have to use perpendicular by base. Perpendicular by base gives me tan theta, remember. So tan, it is theta, theta is 28 degree. So we need to find what is the value of tan 28 degree from the table. AC we don't know, XC is 9. Okay, so tan 28 degree. Let's look at the value of tan 28 degree from the table. So from table it turns out to be 0.53, you can say. Okay, so it is 0.53. Okay, so from here do the cross multiplication, you get AC. So 9 into 0.53. So when you multiply these two, so 9 into 0.53 gives you 4.77. Okay, so it is 4.77. So we got what is AC. Now in triangle BCX, let's say, okay, in triangle BCX, okay, again this acts like your perpendicular because this is opposite to the given angle. Okay, so we have perpendicular, that is BC, by base. Base is XC. Okay, so BC by XC gives you perpendicular base, gives you tan theta, and in this case theta is 13 degree. So we have BC by XC. XC is 9. Now tan 13 degree. Let's look at the value of tan 13 degree from the table. It is 0.23. Okay, it is 0.23. Now let's do the cross multiplication. So from here you get BC equals to 9 into 0.23. So when you multiply, you get your answer to be 2.07. It is 2.07. Okay, now we got what is BC. So we got AC and we got BC, isn't it? So that's why, therefore, the length of the tower will be AB, isn't it? AB. Now can I write AB as AC plus CB? Obviously, right? Now we have, see here carefully, AC is given to be 4.77 plus we have CB. CB is nothing but BC, which is 2.07. Now let's add 7 plus 7, 4, carried over 1, 1 plus 0, 1 plus 7, 8 point, we have 2 plus 4 is 6. So we have 6.84. What is the unit here? Unit is meter. So that's why the height of the pole is 6.84 meter in this case, right? So you pause the video and note down your solution. We have the last question from this particular exercise, and the easy one. So question says, from the top of a cliff 92 meter high, the angle of depression of a buoy is 20 degree. Okay, so let's say this is my sea. So buoy means a floating object. Okay, so there's a sea out there. Okay, so we have a vertical cliff. Okay, so we have a vertical cliff and there is a buoy. Okay, so there is a buoy. Okay, now if you look at the buoy, okay, if you look at the buoy, then the angle of depression is given. So for depression I need to draw a parallel line, remember. Okay, so angle of depression here is this one. So this angle of depression is given to be, 20 degree. Okay, and one more thing is given, that is the height of the cliff is given to be 92 meter. Okay, now you need to calculate to the nearest meter the distance of the boy from the cliff. Distance of the boy, that is this one, from the cliff. Okay, so let me rename it. Okay, so you will say that let AB be the height of the cliff, and let C be the position of the boy. Okay, now here what am I going to do? I'll just draw a line out here. Okay, so in order to make this a right angled triangle. Okay, now I have already told you that due to alternate angles, this angle, okay, this particular angle will also become 20 degree, same as the angle of depression. Okay, now question is asking you what is the distance of the boy, that is C, from the foot of the cliff, that is B. So basically question is asking you to find what is BC. Okay, all right, it's simple, right? This is given, this is given. Now this is perpendicular, this is your base, so use perpendicular by base equals to tan 20 degree and find the length of BC to the nearest meter. Okay, so this is also a homework for you. Kindly try it by yourself. Okay, so with this we close the first exercise on height and distance. Thank you very much.